And since tangent is sine over cosine, cotangent would be cosine over sine because they are reciprocals. Now, does anybody have a question about that? You just simply have to memorize it. Are you okay with that? Now, the next set are called your reciprocal identities, and these you already know. What is the reciprocal of the sine? Cosecant. So when it says on there that cosecant is 1 over sine, you already know that. Reciprocal means 1 over. So what's 1 over tangent? Cotangent. What's 1 over secant? Cosine. You already know that group of formulas, and you may need to look at them a little more carefully, but you already have memorized the reciprocal relationships. All right, everybody okay with that? Reciprocals. You already know those. Sine cosecant, cosine secant, tan cotan. Got it. Now the Pythagorean identities have squares in them. Do you see that? See the squares? Why do squares fit with the word Pythagorean or Pythagorean theorem? Why do squares? A squared plus B squared equals C squared. So we have 3 identities with squares in them, and you need to know them, especially this one. The one that says sine squared plus cosine squared is 1 is huge. This is the fundamental theorem of trigonometry. It's very, very important. Underneath it or beside it or somewhere, would you also write this? These are actually the same thing. Can anybody see what I did? What did I do to get from here to here?
Move the 1.
Moved, and I didn't move the 1, I moved the cosine to the other side. Now let's go back to this one. Could I say cosine squared is 1 minus sine squared? Could I move this sine squared over here? Yep. These are all the same identity. You need to recognize all 3 of these forms. I'm just going to warn you right up front. Section 5.1 is probably the hardest section we're going to do all year. Okay? We got to fight through it. We got to do our very best. All right? I've left out 5.2, 5.3, and 5.4, but we got to do 5.1. Okay? So we're just going to have to tough it out. And that means knowing these identities. So we're going to practice and practice and practice, but we got to know them. I can't memorize them for you, and you can't succeed if you don't memorize them. Okay? So put them on note cards, have mom and dad help you, whatever. Do it on a date Friday night with your girlfriend, whatever. You've got to get these things memorized. All right, the other Pythagorean identities we can do the same thing for. So 1 plus tangent squared is secant squared. So sometimes we see that one as tangent squared equals secant squared minus 1. Now, you'll notice that on the green sheet, the variable is not x. On the green sheet, the variable is theta. That's a Greek letter theta. Have we talked about that before? You do not need to use thetas. You can use x's. When you're memorizing them, you can use x's or n's or a's. It's just a variable. Use whatever letter you want. Now, when we write something like tangent squared, notice I didn't write it like this. Do you understand why that would not be a good way to write this? Why is that not a good way to write it? What does it look like getting squared here? The angle, theta. And we're not squaring the angle, we're squaring the actual tangent. So we don't write it this way, we write it like this. Also, Mrs. Ford is very bad about saying 1 plus tangent squared is secant squared. Now that's true. When I write it, I will never write it without the theta. You must have a variable there. Don't ever write this. Don't write that. If you say it, it's okay. But if you write it, it must have an angle attached to it. okay, like, I may say cosine, but I'll never write COS, I'll always write COS something. Always attach an angle. And then you've got the other one, which is 1 plus cotangent squared equals cosecant squared. And sometimes you'll see that as cotangent squared equals cosecant squared minus 1. So I would recommend that you add this one under that one, you add this one under that one, and you add these two under that one. They are all the same identities, but it helps sometimes if we have them written down, it helps us recognize them when we come across them in problems. All right. Now the co-function identities. First of all, when you look at the co-function identities, do you see how they all have a pi over 2? I stole this sheet from Mr. Thompson. He does everything in radians. What would pi over 2 be in degrees? 90. So if you want to change all those pi over 2's, just write 90 over them, that's perfectly okay. You can use pi over 2 if you want, but you can also use 90 if that's easier. So the first one would look like this if I put a 90 in. Now, these are co-functions. Now, that sort of makes sense because we have sine and cosine, right? Sine and cosine. The word co, or the two letters co, stand for complementary. Do you guys, actually I think that's a D, complementary. Do you guys remember from geometry what it means to be complementary? Anybody remember complementary angles?
They opposite each other.
They equal like one.
Okay, supplementary equals 180,
90.
complementary equals 90. So stop a minute. In that whole list of formulas, what is the one number that's in the whole thing? 90. Every one of them has a 90 in it, every one of those formulas. They are called the co-function identities because they deal with complementary angles. If you have a 90 minus theta, or a 90 minus x, or whatever, you have a 90 in your formula, it's complementary. So if I see cotangent 90 minus theta, see that 90? That tells me complementary, that tells me co-function. What's the co-function for cotangent? Cotangent. The complement, or the co-function is tangent. So tangent theta is the same as cotangent 90 minus theta. I don't think this is computing. Let's try again. I have a secant 90 minus theta. As soon as I see that 90, it tells me complementary co. What is the co-function for secant? Cosecant. Yep. So the answer would be cosecant theta. When the 90s are involved, when 90 is involved, then the things that are equal are tan and cotan, secant, cosecant, sine, cosine, whenever the 90 is involved. Okay? I'm trying to help you think of ways to memorize all this because it's a lot. And then the last set is the even-odd identities. Take a look down that list. What do you notice? Do you notice that when you take the sign of a negative, when there's a negative inside the parentheses, that negative shows up out here? See that on the list? What other functions behave that way? Where does that happen with everything? look at the list of even odd identities. Does this phenomenon happen with everything?
Yes.
Does it? Does it happen with cosine? Is that what it says on the cosine line? No, what does it say on the cosine line? It doesn't have a negative here. So, for some of the functions, if you put a negative in the parentheses, it shows up out here. But for some of the functions, if you put a negative inside the parentheses, it's gone. It doesn't show up. Alright, so let's group up. Which ones go with which functions? These are the two different kinds. What else acts like this? Like cosine? Are there any others that act like secant? Those are the only two, kids, where the negative disappears. Those are called the even functions. The negative disappears. All the other ones, sine, tangent, cosecant, cotangent, all the rest of them are odd. Which means if you put a negative in, you get a negative out. So a quiz question, when we have our memorization quiz next time, a quiz question might be this. I have that one on the board. Tangent negative x. What does tangent negative x equal? Your choices are plain tangent or negative tangent. Those are the only two choices. Which one is it for tangent? Negative. The only ones that lose the negative are these two. Everything else, every other function, if there's a negative in here, there's going to be a negative out here. So, cosecant negative x. Is it negative cosecant x or plain cosecant x? It's negative. Every function is going to be negative except cosine and secant. So secant negative x. Is it negative secant or regular secant? Regular, because this is one of the functions that loses the negative. Only two lose the negative, and they're these two. So you're supposed to be taking notes on your little green sheet. Okay? Now, get out the practice sheet that I gave you. The stapled group of, it starts with a memorization quiz at the top. This is an old memorization quiz.
Yeah. I'll keep it. I'll just get it.
Oh my gosh.
What?
He's on his phone.
What? How dare you?
It's like, how many times do we have to go through this? All right. By the way, don't forget your cereals. I already say that. I want to keep reminding you. You have 2 more days. 2 more days.
Is it over Thursday?
Thursday's the last day. Okay, so here we go. Here we go. Get your green sheet out. Next time we do this, though, you won't have your green sheet with you. All right? So here we go. We're going to fill in these blanks. This is what your memorization quiz is going to look like. I'm going to pick some of the formulas you have to memorize. I'm going to put blanks in there. So here we go. Cosine squared plus what is 1? Sine squared. That's right, Colleen. And when you write that for problem number 1, make sure you write sine squared theta like that. That's what goes in the blank. It's okay. He's all right. All right. Number 2. This one I think you know maybe without looking at the sheet. What's cosecant? 1 over sine. Very good. That's one of your reciprocals. 1 over sine.
I don't think you gave me one of those.
Now, tangent, do you have one, John? You have two?
Tree
Okay.
climbing.
Right now, tangent, look on your green sheet, there are actually two different ways you can describe tangent. How can we describe tangent? What's one way? Right at the top of the paper. Well, that's not at the top of the paper, but that's one of them. You can do it 1 over cotangent, because the tangent is the reciprocal of the cotangent, so that'll work. What's the other one? Sine over cosine. Sine over cosine. And then the last one there, 1 plus what is secant squared? Now that's a Pythagorean because it's got a squared in it. 1 plus what? We're doing problem number 4. What goes in the blank? What makes it's 1 plus tangent squared? Look on your green sheet. You want to end up with secant squared. You want to end up with secant squared, so that's the tangent squared that goes in there. Alright, so now we're going down to the memorization underneath. This is just another version. Your quiz is going to look like this. Alright, so here we go. What goes on that first one? On the bottom quiz now, 1 plus what?
Cotangent.
Cotangent squared. Make sure you put a squared on it. 1 plus cotangent squared. That's the first one. Alright, what's cotangent? One option is 1 over tangent, and the other option is cosine over sine. Tangent and cotangent have a couple of different definitions on there. What's secant? 1 over cosine, and make sure you write cosine theta, so it's 1 over cosine theta, or cosine cube, or whatever. And what goes in that bottom blank? Number 4? Cosine squared theta. Okay. Anybody have a question about what your task is?
When is our actual quiz?
I think I was gonna do it tomorrow.
Tomorrow. Thursday. Well, Thursday.
How about Thursday?
I'll look
I
that
don't
up.
see you Thursday, do I?
Yeah.
If you don't, Fridays are always a good option.
We can't just keep hanging on to this.
You didn't see yesterday. We did see you Thursday.
Yeah, I don't have you Thursday, so.
Go
if I don't
Friday.
do it tomorrow-
Friday.
Friday.
Yeah.
Perfect day.
Friday.
Bless you.
Bless you. Let me think about that for a minute. I don't
Ponder
want
on
to,
it.
you
Take
guys
your
will
time.
just put it off and you'll learn it all Thursday.
Hey,
And in
bro,
the
chill.
meantime, we're struggling because we won't be able to do the work we have to do. Because get your note sheets out. You need to know this stuff. Leave your green sheets out. Get your note sheets out and turn to page 39.
I'll probably go away.
What? Ah, pre-surgery.
Alright, so on our note sheets, which were used in chapter 4, try not to be bored, this is fun. It's gonna be different than anything we've done so far, that's for sure. Same note sheet you had before, go to page 39. Alright, we're on page 39. First problem says simplify. Wow, this looks complicated, but don't be afraid, Robbie. You can do this. These two are not like terms. Would you agree with me? So when it says simplify, I'm not going to be able to add them together. That's not going to work. Page 39 of our note sheets. Do they have anything in common? No, they aren't the same, but do they have parts of them in common? What do they both have? A sign. So I'm going to go ahead and factor out a sign X. I'm going to take out one sign X. Now there are three of them here. So when I take that one out, I will be left with a sign squared. Yep, I'll be left with two of them. Plus, all right, now remember, we're taking out the sign. So what am I going to be left with here? Cosine squared. Oh my gosh, ding, 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 ding. Buzzers are going off in my head. Look at your green sheet. What is sine squared plus cosine squared? 1. So this parentheses is just 1. So now I have sine x times 1, which is just sine x. So your job was to simplify that, and you sure did. Look at what you started with and look at what we ended with. So how did we accomplish that? We looked at it and said, well, they're not the same, but they do have something in common. So we factored it out. And then what was left was an identity, a formula from our sheet. Everybody okay with that? All right, let's try the next one. No, we are not on the practice test. We are in our notes. And if you threw them away, you're in trouble because it has all of chapter 5 in your notes. We're on our note sheet. Okay? Take a picture of somebody's and work on notability or whatever. Who has an idea here how to start? Back or foil it together? Would you agree when you look at that you maybe could foil it? All right, let's see what happens. First times first would be secant squared. And remember when I do my squared, I put my squared after the function, not after the x. That's secant squared. All right, now outsides. Outsides would be minus secant. Insides would be plus secant. And last would be minus 1. Good first step, foiling. Good idea. All right, what do you notice?
The middle.
The middles cancel, all right. So now I've got secant squared minus 1 over sine squared. Now I'm old, I do this for a living, and I happen to love this kind of stuff. So bells are going off in my head. Bing, 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 bing. Look at your note sheet. Remember where it says 1 plus tangent squared is secant squared. What did I ask you to write right underneath that? Tangent squared equals secant squared minus 1. What's in my numerator there? Secant squared minus 1, which is tangent squared. You okay with that? Now, tell me about tangent? What does tangent equal? Sine over cosine. Tangent is sine over cosine. So I'm going to take that tangent squared, and I'm going to write it as sine squared over cosine squared. That's this right here. This is sine squared over cosine squared. Now that means sine squared over cosine squared divided by sine squared over 1. This is a fraction, so this is divided by sine squared over 1. What do I do when I divide by a fraction? So it's sine squared over cosine squared times 1 over sine squared. What's going to happen? Yeah, they're going to cancel. And what am I going to be left with? 1 over, not cosine squared, 1 over cosine squared, which you can leave just like that. Or, could you rewrite that? You can leave it like that. I'm perfectly okay with that. But you could rewrite it as secant squared. Because what's 1 over the cosine? The secant? So you could write it that way if you wanted to. So again, this is what we started with, and this is what we ended with. Did we simplify? Yo, we sure did. That's your job. That's what we're trying to do, is simplify. I know it's hard. You just have to hang tough, guys. We will practice, but this is hard. Okay, next. Think of it as a puzzle. Some kind of puzzle. We're trying to figure it out. What?
1 minus sine cosine.
Oh, awesome. Let's talk about that. Actually, it's not quite right, but I'm glad you brought that up. The identity, the thing I had you write on your paper, says 1 minus cosine squared equals 1 minus sine squared. Is this 1 minus sine squared? No. So the Pythagorean doesn't work. They have to be squared. So that is a great idea. I completely and totally love it, but it's wrong. Can't do it. Okay, that's tangent, no question about that. However, that's not going to fix my bigger problem, which is I have 2 fractions here, don't I? And I'm trying to subtract them. How do I subtract 2 fractions? What? I get a common denominator. Now, let's do this carefully. You guys stay with me. Try not to zone out. It's hard, but it's not going to get any easier if you zone out. What would the common denominator be? It would have to have this part and that part. So this one is going to get a cosine, because that's what it needs. And this one is going to get a 1 minus sine, because that's what it needs. So you figured out your denominator is both of these things. So this one needed this piece, and this one needed this piece. Now, are the denominators the same now? Okay, so I'm going to write 1 fraction, because the denominators are the same, and here they are. So here it is. There's the denominator. All right, what have we got here? What's that? Cosine squared.
Why'd you put 1 minus sine x?
So down here?
No, on the other side.
Over here? Okay. Remember, the original fraction had a denominator of 1 minus sine x. So if I'm going to add these together, the denominators have to match. So since that one had a 1 minus sine x, this one needs a 1 minus sine x. And that's why the cosine's over here, because this one had a cosine, so this one needs it. The denominators have to have the same things. Okay? So now my numerator, because I put that extra cosine in, is now cosine squared, minus. Alright, and what am I going to have here? Do your distributive property. That's going to be minus sine x. And then what? Plus, because it's a negative negative, sine squared, yep. And now I got buzzers, fireworks, bells, everything's going off in my brain right now. Because I've got cosine squared plus sine squared. And what do these two make when you put them together? They make what? 1. So now I have 1 minus sine x over cosine x times 1 minus sine x. Wait a minute. They cancel. 1 over cosine. Bingo. That's your answer. If you want to write that as secant, you can, but you can leave it as 1 over cosine. That's fine. That's pretty cool. You have to admit, that's pretty neat how that worked out. Okay, we're going to do a couple more. These are easy. This one's easier. Number 4 is real easy. We've kind of done the hard ones already. I think now we're in for a little bit easier time now. So first problem, or number 4, first one we're going to do here are the easy ones, says cotangent over cosecant. All right, tell me what you think about this. Well, what's cotangent? Well, it's 1 over tangent. What else is it?
Cosine over sine.
Cosine over sine. So almost always you're going to want to change into sines and cosines. So that's going to be cosine over sine over, okay, that part's just cotangent. What's cosecant? 1 over sine, that's the reciprocal of the sine. Now you have, I know it looks a mess, but don't worry, it's a division problem. You have cosine over sine divided by 1 over sine. Well, what do you do when you have cosine over sine divided by 1 over sine?
Multiply by the reciprocal.
Multiply by the reciprocal, so, and it's always the reciprocal of the second one. The reciprocal of the second one. And what happens when you do that? When you turn that second one over? What happens? We get some canceling going on. And it comes down to just cosine. Remember, your job is to simplify it. So you are doing that and doing a great job. Number 5 is very similar. So let's see if you can get that started on your own. Think about what we just did over here. Think about what we did in this problem. Could you do the same thing with number 5? Get your green sheet, or I think you already know what that is. What's cosecant? You don't even need to look at the sheet. What's cosecant? 1 over sine over, what's secant? 1 over cosine, right? Now, we have another one of these big division problems, right? So we have 1 over sine divided by 1 over cosine, which will be 1 over sine. Remember, you always flip the second one, so it'll be cosine over 1. Now, nothing cancels. But you can put these together, and what would you have? Cosine over sine, which is cotangent. They're not too scary, are they? All right, one more. Hang in there, folks. One more. Anybody, look at your green sheets. Look at very carefully. If you wrote down what I asked you to write down, if you added what I asked you to add, you should have an idea what your first step would be. It is, Emily. The top is 1 minus sine squared. 1 minus sine squared. The identity that says sine squared plus cosine squared is 1. Underneath it, I asked you to write cosine squared equals 1 minus sine squared. That's how she did that. Cosine squared is the same as 1 minus sine squared. Put you on it. Here comes the tricky part now. Why are you all so tired today? Or am I just exceptionally boring today? 1 minus sine squared is the same as this. What would you do with 1 minus a squared, or 1 minus x squared, or 1 minus something squared? It's called the difference of squares, and it factors in a special way. How does the difference of squares factor? Do you remember? 1 minus a and 1 plus a. So let's come over here. I don't have an a squared, I have a sine squared. How's that going to factor up there on top? 1 plus sine x, 1 minus sine x. That's the difference of squares, kids. The difference of squares factors as 1 minus sine and 1 plus sine. Now, what was good about that? Now we can cancel, and the simplified answer to the problem is just what's left, which is 1 plus sine. All right? Now, here's the deal. I'm going to cut you a deal. We will have our quiz, what did we say, Friday? It has to be Friday?
Yep.
We'll have our memorization quiz on Friday, but in the meantime, I expect you to be memorizing them so that you can participate in class as we're simplifying our stuff. Okay? Anybody who misses Friday is in here Monday morning before school to take the memorization quiz. All right? We're not making it up for weeks.